Hey, Todd Mariana here, and I'm going to give you the update. So we worked the entire night straight, and this is kind of the design that we were going for. So what we've done is we've made a full drop-in replacement for Gale Force. And it's all in .NET Core, so this is entirely portable, not only server end but client end. We are using absolutely zero dependencies that cannot run on Linux or Mac. So what we envision is at client sites, they will run a service or a daemon. It's the same code, and that will also run .NET, ASP.NET web application, which also has a web API. And so what's going to happen is the service is going to, over the internet, call home to a web API that's hosted by us. It's going to ask for whatever files need to be downloaded from the database, and those files are then going to be returned by ID back to the client, which is the service. Okay, the service will then spawn download executables, which again are portable, 100%, and those download executables will then go ahead and ask the server for the full details for the file that it needs to download, and this includes many different customized settings for how that download can occur, which includes a custom DNS server specification, throttling for each one of the threads that it opens up, the specification of how many threads it's going to host, what the buffer size is for the download, many of the current properties that Gale Force uses to make sure that the download is going to happen correctly on the person's network, regardless of what their speed or reliability is. That's all built into the data that we return to this. So this gets some metadata about the file it's going to download. It then goes out to the internet and downloads a file using 1 to n threads that's specified by data in the database. Each one of these download executables can be communicated with from the service that spawned it via a named pipe. That named pipe includes the process ID of each one of these executables. So at any point in time, this thing can ask this executable to restart a thread, or to throttle itself differently, or to abort, or to restart itself entirely. There's all sorts of options, and in fact, it's a flexible, extensible protocol for commands. So we can make whatever we want, we can implement there. And it's going, again, over a named pipe that includes the process ID in the name of that named pipe server. So since this is spawning these processes, it knows the process IDs, therefore it can communicate over that named pipe at any time. It can also ask this executable to upload status information to the web API that it hosts. So this is a one-way form of communication that just says, hey, do something. This then will allow us to gather statistics about all of the threads in all of the download applications that are currently running on a system, and it can report that information back. It also has a local database that it saves information to, and that local database is a SQLite database, which is totally portable. So this is 100% drop-in portable solution running on .NET Core 1.1, and I'm going to demo it right now. So what I have set up is, we're gonna try downloading from the CDN. We're gonna show you that there are 5 threads that open up that start to download segments of the file. We have the ability to run a hash either on a segment or on the entire file after it's been downloaded. So we can, in fact, do an inline hash, and we can reject a segment at certain points. So we could add data to the database that stored maybe 20 or 30 hashes per segment, and that way we could bail on a segment very early if it fails hashing for any reason. So here we go. We're going to run this. And that's the web API starting up. And what we are going to see here very soon is a specification of threads. Boom. Those are all the threads that are running. I've got 5 going, and they are each downloading bytes of information from the CDN. And so at any point in time, if I wanted to, I could restart any one of those threads. Right now I'm going to type in the command to say restart -all. And there it went. The threads restarted, they reconnected to their source, and they went happily right on, doing exactly what they're supposed to do. I'll do it again. So that's a command over the name pipes. It's actually also telling the executable to check in and commit status back to the local web API, such that somebody could run a web-based interface and actually not only control, but see the progress of all the downloads and all the threads. So this is Project Dash, and it's ready for prime time. We can download a 400 megabyte file reliably in less than 10 minutes. That's 100% reliable. We could definitely transfer feature films using this technology.